All right, so hopefully, as Des mentioned, my name is Mark Chambers. I'm with Plato Software. We are a software company. So my intention this evening is to take you through my experience and what I've seen with industries I've worked with, some very large automotive OEMs, Tier 1, Tier 2, med device pharmaceutical companies, even some of the military programs I got involved with, to look at what are those challenges that they continue to face and how can using applications, not necessarily like ours, but software applications, help address some of the challenges that organizations continue to face. More so now, for those that are on the call that are automotive, you've probably seen the new AIG VDA guideline that's come out. There's a lot more complexity to it. It's very system or model-based engineering where we're looking at complete structures that represent a product and a process. And the challenge that a lot of companies are now facing that I get to speak to on a regular basis is how am I going to manage that information when we're stuck using Excel spreadsheets or we're stuck using outdated software tools. So what you're going to hear this evening, and I've only got a few slides, is we're going to talk about, or I'm going to present to you, from my perspective, having been in this field for 20 plus years, what I've seen, the lessons I've learned, and how using applications like what we offer can help a lot of these companies address some of those challenges, whether it's non-compliance, whether it's major minor findings, whether it's looking at new technology coming out and how it's going to be adapted to evolve into the particular platform. So we're using WebEx. I will admit it's not my favorite platform, so if it does lock up, it's not me, it's the application, technology. So hopefully we're going to be smooth sailing from this point forward. Des, I want you to let me know if there's a problem so I can address it, okay? One of the things now, some of you that have, okay, so some of you that have been to the ASQ Toronto chapter, I presented probably 3 times now. So some of you may see some of these slides from before, but it's still relevant. And it's more relevant now when we look at the number of recalls that are happening, when we're looking at the number of new methodologies coming out, the demands from the SAE with the new J1739, the AIG VDA, all of these guidelines. Organizations have so much information, and it's unfortunately in the heads of the engineers, or it's on Excel spreadsheets and documents spread out across the entire organization. It's very difficult to make intelligent decisions on how to identify and mitigate that risk in your particular process or your design when you are drowning in information. There is so much knowledge out there that there are a lot of the companies we get to talk to are frustrated and challenged with being able to capture and leverage that knowledge in those senior engineers' heads. They can then transfer that down to the next generation of engineer coming in. And what that means is that the technology continues to evolve. We see with the new vehicles coming out, with the autonomous vehicles, with the vehicles with LiDAR on them, with active braking, where we're monitoring and we're actually responding to situations ahead of the driver. If the technology is evolving, but our approach to risk isn't, the methodology behind FMEA, the fundamental risk management platform or method from the back in the 60s, hasn't evolved really beyond what we've now got as an AIG VDA guideline. Right? What we look at as a software company is how can we help companies that are automotive, med device, pharmaceuticals, where they are continuing to advance with technology to be able to actually identify, manage, and mitigate that risk before it actually happens. We see in the news all the time that the recalls are continuing to happen. But why is that? Why do I still see in the paper Ford having recalls, Tesla having recalls? It's not just automotive. It's every other organization I get to work with. I've worked with everything from companies that make coffee machines to dryers to obviously aircraft and automotive. And they all have the same issue. And it comes down to 3 things. One is the culture in the organization. So it's the people. How risk aware are they, risk adverse are they with the organization, right? It's also looking at the technology they have. Now, we all know since the first FMEA was written, everyone's been working with Excel spreadsheets and Word documents, or they've hired an IT company and built something internal. And then you actually have the process is the third thing. It's actually the process itself is how we go through and identify that risk and how we identify how we're going to mitigate and control for it. Now, there are standards out there. Well, we've seen them all. I have the new one on my desk, in fact, and it's just another spin on this same traditional approach to how we manage that risk. The challenge is that the actual methodology is now getting more complex, and the traditional approach, that traditional process or that traditional technology that you may be using isn't going to deliver the results you're going to expect it to do, which is why we have a lot of companies now coming to us saying, I need to be able to get my risk in order, my house of quality in order. I need to be able to actually identify and mitigate that risk much more efficiently and much more accurately than I have been in the past. So why is that being so difficult? Why is risk so difficult to manage? And it's because we become complacent. Unfortunately, and I get to work at a lot of companies, I'm amazed at the amount of times I hear the same thing. Well, I worked with in the past. It ain't broke, why fix it? Yes, it is, but how many findings have you had? How many minors have you had? How many majors have you had? I have 3 clients right now that I've been working with locally here in Toronto that called me up and said, Mark, we have a problem. We need to come and talk to us. Their issue was they actually were delivering product to one of the OEMs here in the area, and their product, when it got off the racks going onto the line, was found to be non-compliant. It was defective. They brought in supplier quality. They went through the process and identified actually your documentation is not correct. Your documentation has disconnects between the process to the control plan. You identified certain operations in one stage that are not on the other document, so you're out of control, right? So it becomes a non-compliance issue. And we hear this a lot now in the organization. And why is that? It's because the data has become unmanageable. As the processes become more complex, as the products become more complex, you have way more data than you actually ever had before that you're trying to manage. I had an FMEA sent to me last week, a design FMEA, from an OEM that is 25,000 lines long. It's impossible to manage that amount of data. And it's not just automotive. Like I said before, we see it in every other organization. They all have the same challenges. And that's why companies like us are able to help these organizations, because we have a better way to do it. I'm going to show it to you in a minute, is what you could consider as the future for the way you want to manage that risk within your organization. And as I mentioned, it's a decade-old problem, and it's not just automotive. I've seen the exact same situations that I have with automotive clients that are making door panels to med device companies. For those of you that have been in my sessions at ASQ, back in my early career, I was an expert witness on a med device that malfunctioned. And it malfunctioned during a routine operation, causing a recall. The problem was that the company, a European company, had designed this piece of equipment to deliver liquid anesthetic in a vapor, and it malfunctioned during a routine operation at Sick Kids in Toronto. We were hired by the law firm to go and reverse engineer that piece of equipment to identify, using fault tree and FMEA, how narcotic poisoning could actually occur and what the probability of it was. What we identified, our findings, was the med device company had not considered over 180 failure modes that could occur from the anesthesiologist operating the equipment through to the actual med device itself, malfunctioning, resulting in narcotic poisoning. Our documentation was used as evidence against the manufacturer in the court, and unfortunately they lost very heavily, very expensive. But the point is that the documentation that you generate, your FMEAs, if you are using and developing LiDAR, for example, or you're developing driver assist platforms, or the latest pharmaceutical drug, your documentation can be requested by CORE at any point in time as expert evidence as to whether or not you identify the level of risk and how you're going to mitigate it. And that's something that we're now seeing a lot more. The lawyers are becoming more involved. And I don't mean to be doom and gloom at this point, but my point being is that your documentation has to be accurate and correct to help to mitigate your chance of having a litigation suit. But what causes that problem is the question, and it comes down to 3 things. There's no visibility. A lot of companies I get to work with, and as I mentioned, I've been doing this for 20 plus years, they have no clear idea where their risk actually is. I have a client right now I'm working with that has 35 sites globally, and they are looking for a way to identify where is the risk in my organization. What are my top 5, top 10 risks across my manufacturing lines, because we run the exact same product through multiple lines across the globe. They have no way of identifying it because they're using Excel spreadsheets, right? There's no clear way of being able to identify where's the risk, where's my top 5, my top 10, are we improving, are we getting worse, right? Because it's the traditional approach. What worked in the past will work for us now. Well, no, it doesn't. The YouTube generation that are coming out of engineering universities are going to expect to have applications in place that help them to improve the way they design and manufacture product. Okay, it's a given. They will expect knowledge to be transferred to them to be able to make better informed decisions faster than before because they have compressed timelines to get product to market. That standardization is key. They have to have the same methodology. If I'm looking at one FMEA from one part of a vehicle or an aircraft or whatever it is, or a process, it should be the same as the other one. I have a client in Michigan right now that has 13 different standards for their DFMEAs. Everyone keeps creating another one. Everyone has another great idea for another column to add to their FMEA, so they go ahead and do that. Well, there's no standardization. Even if you put the guidelines in front of them, even the new AIG VDA guideline, if we gave that to the organizations that this is the new methodology we have to follow, I guarantee you by the time that document hits the desk, somebody's already invented another version. They've already added another column. They've already modified certain content in it, right? And that drives part of the problem that we have, as well as silos of information. Historically, I designed something and I'd throw it over the fence to manufacturers and say, can you make this? And they'd come back and go, no, we can't. It's out of our, we don't have the capability with our machines to support those tolerances. Or it's I have groups in one location not talking to another one. It happens across the globe. I went to Germany about 3-4 years ago, and I had to facilitate a workshop because this company makes environmental controls, and they had a problem where they were getting back 4 million euros of product shipped back every year because it was defective. So they bring everyone together in one room from all over the world, and they start to hammer out how is this happening, because it's repeatedly happening every year, and what is the problem. So I was leading the facilitation, going through and exploring design, looking to design all the knowledge that we could capture from the groups, lessons learned, digging into some root cause, looking at some 8D, and then get into manufacturing. It wasn't until we started to go between design and manufacturing that a group at the back of the room that were from the facility in Mexico stood up and interrupted the meeting and said, actually, the problem you're identifying, we fixed 3 months ago. But we didn't know this. The company in Germany, the head office, had no idea that the problem had been addressed by another facility and they had just not corrected it and had not notified anybody else. And that was because they had silos of information, knowledge not being shared, no standardization or approach to how they could deliver the process. What that results in, 80%, and this fact is still true to this day, 80% of all quality issues have actually been happening before, and we've done nothing about it to fix it. Engineers will spend 42%, it's actually more like 45 to 50% over their time trying to find relevant information to make a better informed decision, which means either asking Bob, who's been with the company 40 years, or digging through an existing Excel spreadsheet or a documentation to try and figure out, has this happened before? What was the cause of it? How do we mitigate for it? Or if it continues to happen, why is it happening? Right? The end of the day is that companies will spend on average 20 to 25% of their actual revenue every year fixing the exact same issue and not really addressing it and fixing it. And it comes back to those three things I talked about. No standardization, it's the poor communication between the different divisions, it's also looking at it, the tools, the process, the culture within the organization. What that results in, and this is what I've seen, these are my top list of what I've seen from all the companies I've got to work with. No teamwork collaboration, no one talks to each other, really. We've got disconnects. Customer expectation flows to design, design doesn't pass to manufacturing, or customer doesn't pass it to design, so there's a problem when it hits the market, like we had with the ignition switch. You may recall that one. Action items is another one we often find, and I have gone in and I have audited FMEAs, and I start to pick through them. I'll start looking for things I know I'm looking for. things like action items. I had a client had a FMEA, process FMEA, where they had RPNs in the 160 to 180 range, and their recommended action was not applicable or not required. It's like if you identify a risk, a high risk with a high severity, how do you not have a recommended action? It's looking for this type of information, right? There's no proactive knowledge capture. It's in the engineers' heads. They just leave the organization. They go to a competitor. All of that knowledge walks out the door with them, unless you have a way to capture that information centrally. Another big one is field failure information, not being cycled back into engineering. Has this happened before? And what was the recommended action? How do we prevent it? If it hasn't happened before, what do we do to design what's a root cause or to do a deep dive to identify this is that particular problem, right? And then here's how we're going to address it. I have clients I work with now that make very big yellow construction equipment. They actually have now tied in their warranty information and their 8D or their lessons learned database into their NPI process. So as an engineer is now designing the next big piece of equipment, he has access to this knowledge. He can identify how did that ram fail in the past, or what was the warranty issues with it, what is the field text telling us about it, and all of that knowledge is now being cycled into the new design. Right? So we continue to evolve and improve every design because we now have access to this information through various products, through various databases. We look at organizations that have grown through mergers and acquisitions. That makes data unmanageable because they are trying to manage multiple systems, right? You've got organizations that buy one product because this division likes this application, another one buys this application, they don't talk to each other. Right? We are now seeing a lot of organizations, especially for an IT initiative, where they are actually downsizing the number of tools they have. They're now actually going through and decommissioning the old platform, saying, listen, we have one solution that we can put in that will address the needs of the design and manufacturing, and will talk to the other systems. And this is where the whole Internet of Things, the Industry 4.0, is all coming from, right? Quality 4.0 is the ability to connect systems together where they can talk to each other and share information. And that's the real advantage of companies like us and where we are now, is we have that type of technology. I'm going to show it to you. So what's needed? And this is kind of leading into what I'm going to show you without trying to sell you the software. We need to have an intelligent platform that's scalable to my organization as it grows, that can be accessed from anywhere in the world, that allows any engineer with their particular role to be able to log in, work on their design, work on their process, get proactive information, knowledge, and communication with their entire team in real time, regardless of where they're located globally. And the application should empower and enrich my team, my people, the processes we have in an organization. I don't know. Yes.
Your screen is frozen.
What screen are you on? Are you on the last one?
Yeah, what's needed, yeah. Go to the next one.
Okay, you had lag on your, maybe lag on the WebEx. Yeah. So platforms that leverage those three key things, right? You can train people to do a certain thing. You can deliver the latest technology, but if your process is flawed or there's issues in your process, you're not going to get the results you want. Conversely, if you've got the best process in the world, because you follow ISO and you follow all the regulations, and you've invested heavily in software, but your people are the problem, that's not going to work either. So we look at, when we go to work for companies, and we do this as a service, we'll come in and we'll sit down and go, okay, let's take a look at the the key three things. Your people, the culture, what's it like in the organization? How well are they versed in risk management, in their training programs, in methodology, what's their grounding overall? Then we look at what are those processes you have. You have a new program starting tomorrow. What does that process look like? How are you capturing the requirements? How are you getting the CSRs from the OEMs? How's that driving design? How's design talking to manufacturing? So we look at that process. And then the last thing we look at is what are the tools you're using? And then what are you using for design? What are you using for your designing your product? What is the engineering, the quality group using for their DFMEAs? If they follow APQP, what's that process look like? What are the tools they're using? And then we start to identify gaps in each of those three things. And then we start to look at how can we help you. We have in our organization, Des did mention it, but real quick background on Plato. We are a software company, but we're also a services company too. So we have consultants, there's a team of them, some based here in the US and some in Germany, that will actually help consult and advise organizations, regardless of what industry you're in, on how you can become better at the way you design and produce product. Okay, my group, the one that I work with, is purely on the technology side, but I also have obviously worked with and experience with people and process. So that leads me into this slide right here. What makes us different? Okay, the product I'm going to show you is used by the majority of the tier 1s, tier 2s, and some of...
Your slide is lagging a bit. You want to just reload this one, just go click back and forth. Yeah,
okay.
Thank you.
You got it?
Looks good now.
Okay. So the product I'm going to show you is called Eins. It's a German word for one. We're a German software company. We're based out of Lübeck in Germany. That's our headquarters. I'm from our offices here in Markham. We also have office in Dearborn in the US. And Eins means one database, one platform, and it is 100% web-based. In fact, the demonstration I'm going to show you is me logging in from my office here in Markham, but my actual server is in Germany, okay? So we don't do just FMEA. That's one thing I want to mention. When you see the application, we get involved in 8Ds and auditing. We get involved in functional safety. We get involved in, if you're on the med device side, RM 14971. We have all of these different methods, we call them, available for you to use when you're developing and building out, whether it's design or process, your FMEA documentation, the full APQP, within one central platform, right? We bring all the teams together. So Des, who's my colleague, who could be working on an FMEA, I could work on an FMEA, but it's all part of the same deliverable, and we're both getting notifications. We're both getting updates as we're making changes to the application, okay? It uses a very simple web UI. It's got a relatively low learning curve. It's like a one-day. It's a very low learning curve. It works like Google. You can search for literally anything. I want to find a failure mode, I want to find a part number, I want to find a recommended action. I can simply type in what I'm looking for. It'll start data mining the entire database and brings back a summary of all the information that's available to me. All of the functionality, the forms, we call them methods, work just like your Excel spreadsheet, because Excel is our #1 competitor. 75% of the people we talk to are still working with Excel spreadsheets. And I'm sure a lot of you on the call are still doing the same thing. So it works much like an Excel spreadsheet. It's got a big database behind it, which allows us to do a lot of wonderful things, from data mining to reports to dashboards on all of that particular data. The end game of this platform is to help you as an engineer or you as an organization to make better informed decisions on how you identify, manage, and mitigate the risk to the product, to the process, and to your organization. Okay, to make better informed decisions is key. So I'm going to change over now, and hopefully everything goes according to plan. You should now see my login screen, Des?
Yeah, it's good, it's good, it's good. I'm good to go?
All right, perfect. So I'm going to log into my system. This is my platform in Germany. Log in my password. Okay, so I'm now logged into the system. First thing you're brought to is this search bar. Pretty plain screen, really. Doesn't tell you much. A real quick orientation for you. Down the bottom here, this tells me what was I last working on. Maybe I was working on an FMEA, maybe I was doing an 8D, maybe I was working on a block diagram. All of that functionality is in the system. Up on the top right, I have notifications, so I can see who's been working on my projects, who's been modifying, adding, deleting content, adding new requirements, adding new functionality, right? I can also search, of course. On the left, we have all of the different functionality. This is one web-based application that is and can be scaled all the way back to a single facility with 3 engineers. And I have one in particular in Scarborough that's a new customer that make door panels. And they bought one instance for 5 engineers, and that's all they use it for, is for doing PFMEA, process flow control plan. The goal of the platform and what it's designed to do is to link all of that information together. And for those of you that have seen and been to the training for the AIG VDA guideline, you'll appreciate this, in the EINS was built around VDA, okay, because we're German. So we already had 90% of the AIG VDA guideline functionality in our product, which includes system models, or model-based engineering, you might say, right? And I'll show what I mean by that in a minute. And a lot of that functionality you'll get to see now because we link all of that information together. I link everything from the initial requirement for my product all the way through to my inspection plan. So I can start to identify design characteristics, process characteristics, and it will link information from my DFMEA, such as the class, such as the specification, into the appropriate column on my control plan as a design characteristic. So I have a product that I've been working with. It's a charging device. You simply start typing it in. EINS will then bring back a summary table and says, okay, this is what information I can find. If I wanted to, I could also go over to the right here, and I could expand that further and say, okay, I'm looking for a particular part, I'm looking for a particular program that it's involved with, or a particular methodology, and I can then simply drill through that, right? Real quick, across the top here, we have a system element. And I get asked this a lot. What do you mean by a system element? A system element in your world is a line item on a bill of materials. Could be a starter motor, could be a syringe, could be a med device, or like a pump, for example. It can be anything that drives your design or your manufacturing process. A system element is not specifically tied to one thing in the database, and I'll show what I mean by that in a minute. Aspects are block diagrams. Okay, we actually allow you to build live, like you would if you were working with Visio, functional block diagrams that allows you to actually see how all these different blocks that represent my product are linked together. What are the interfaces? And then also be able to link back all of the information, such as what are the primary functions for these blocks, all the way through that information. Real quick, other things we have in here, FMEA sheet or form sheets, excuse me, those are your actual methodology, your forms you're working off, whether that's PFMEA, DFMEA, requirement, specification, whatever it is. I have 450 of them in my system. I've got 6 folders containing engineering content, and I've got 2 actions, and I've got 29 FMEA actions. Why the actions are double there, I'll explain. Everything in EINS is tied to a project, okay? And that project can be design-focused or manufacturing-focused. What that allows me to do is I may have team members like Des, for example, that isn't touching any of the FMEA, but Des is involved with compliance, or customers works with ROEMs. I need Des to go and get all the information for this new program and put it into the system so my engineers have access to this information, to the design requirements. So that would be a regular action sent to an individual that's not part of the FMEA team. The FMEA actions, and I have 29 of them, those are for people that are involved in actually doing the FMEA, whether it's design or process. So you have recommended action, you have to complete it. Whatever you put for actions taken, the system will update the record in the FMEA. Okay? And then we have process flows built into this as well. So I'm going to jump in, I'm going to take a look at one of the projects I have, which is a charging device. And I'll take you through how this works. So we have obviously different functionality available to you. The one that I like to use a lot is the Architect, because it kind of works the way I do. So in here I have a project, and you can see I have a number of different projects available. Some of these are clients I'm working with right now. What I'm going to look at is this charging device, so I'm going to focus on it. My charging device is broken down into parts and products, along with manufacturing steps. Okay, so you have on the left here what we call a system tree. This system tree basically is my bill of materials for my product, along with all of my manufacturing steps. Okay, so then I can choose a product. Okay, so I say I'm looking at this particular part right here. EINS works on the premise of left-hand and right-hand view. So on the left-hand side, I can walk up and down that tree structure, and on the right, I can choose what I want to see. Okay, there are no files. There is no file open, save as, copy in the system. Everything is database driven. As soon as you type something and you tab to the next field or you hit enter, it's committed to the database. As soon as it's committed to the database, any engineer involved in the project has access to that data and they can view it. What I'm looking at here is I have a top level product, which is my charging device. This is what I'm going to deliver to my customer. It has these primary functions, okay? I can also say, let's look at the potential failures. What I don't want to have happen to my product in the field. So I have this requirement from the customer where my product has to charge to 12 volts. I have an undesired event or a failure where my client can't charge it, which is going to cause it to come back as a warranty issue. I also have down the left here a breakdown of all of my sub-assemblies, their functions, and their corresponding failure modes. What I'm able to do is I can start to look at, if I get that no power failure on that sub-assembly, does it have a direct influence on my overall product failing in the field? So I can start to look at design component level failures and how they have a direct influence on the parent or the overall product not meeting that functional requirement. But I can also do the same thing from a manufacturing point of view. I could go down into my manufacturing and say, okay, looking in manufacturing, if I have a particular failure mode in manufacturing, I'll just find one in here, where we have the wrong bill of materials in manufacturing, that's going to have a direct influence on my product failing in the field at my customer. So the product you're looking at here called Architect, it was previously called Matrix in an older version. Its purpose is to allow me to look at, for example, failures. And I can build function and failure nets, which is basically a visual representation of my DFMEA or my PFMEA. And what it's showing me here is if I have the failure unable to charge at 12 volts, it's going to result in my customer being unable to use the gas measuring device. It's going to be unable to charge. Its function is it has to provide constant power, but if I look to the right, I'm actually having from multiple levels in my FMEA failures driving me to have that loss of function, resulting in me having that failure occur. Okay, and we can put metrics around that too. This functionality right here is actually going to drive a new feature we have coming out at the end of December, which is fault tree built into this as well. Okay, so we can look at this way. I can simply navigate up and down my structure, and I can view all of my corresponding data, and I can see exactly all of the different items and how they're connected together. Perhaps you don't work this way. Perhaps you're more visual and you want to work with the application looking at it from a block diagram point of view. So what we can do is we can tell lines, okay, I want to go look at block diagram. So in block diagram, I can visually create different blocks to represent my product. So I can choose, for example, my charging device. I can drag out these blocks to represent different assemblies and sub-assemblies. I can connect them together, and I can then start to model the overall structure of my product and the interfaces. I could say, for example, this is a plug fit or a clip. This is a physical connection. This is a solder connection. And I can start to look at visually the blocks that represent my product, right? What this allows me to also do is I can drill down into sub-assemblies, and I can start to look at the underlying, lifting the hood on the car and say, okay, let's look at this inside. What we got? We got fuel pump, we got starter motors, we've got ignition system. Those are my sub-assemblies. Drill down into the ignition system, pull out the coil. So you start to build a layered block diagram, but what INS is doing is maintaining the connection throughout the structure, which is shown here. I know, for example, that block has two primary functions. It also has a subsystem. This one has 5 functions. If you're involved in functional safety and you've been doing functional safety analyses on that charging device, INS will also show you what is the corresponding ASIL for that function for that block. It's linking functional safety into the block diagram, okay? And also linking requirements and specifications, okay? You can link any number of these together. You can see here I have airbag system, rack housing, any different type of configuration you want. It's just like working with Visio. Okay, moving in, if you're in manufacturing, we have you covered there too. I can go down to manufacturing, for example. I can go in and say, I want to look at a flow diagram. Same way we do like with block diagram, I have visual process flow. This is linked all the way through your documents, from the process flow visual to the process flow table to the PFMEA, to the control plan, to the inspection plan. Likewise, these blue triangles are telling me that I actually have identified key characteristics for that operation that are on my control plan that I have to make my user aware of in his process flow. So it's linking back from control plan to process flow. So here I can see I have two primary operations. Whatever you type in here for the operation number, in this case a 10, and the description, the process step, is going to automatically appear on the PFMEA and on the control plan and on the inspection plan. Okay, INS links all three documents together, and we can look at that right now. So I have these operations, I have this flow of how I'm going to make my product all the way through my manufacturing line, right? This works the exact same way with block diagram or aspects. Drag and drop the operations, give them a number, give them a process step definition, and then INS automatically links it into manufacturing right here. So in my process flow, I have what you might be familiar with is the tabular format for your process flow. In here, it's read the operation number and the process step from my visual process flow. It's read the symbol that I identified. In this case, it was an operation. This is a decision. It's also read the actual flow I defined visually, each operation and how they're connected. So it's now showing this proceeding of subsequent steps. We also can call out whether it's machine or device. I'll explain why we do that in a minute. And then we see here we have our product and process characteristics with the corresponding class symbol if it was applicable, and also the specification and tolerance. If I then say I want to look at the control plan, there's the same information on the control plan. I could go through and say, where is that process characteristic coming from? Because we need to change the class symbol. So I could simply click on it. INS will jump me over into the corresponding PFMEA. Says it's right here, specification. I change that class symbol to a CC. I change this parameter to a 6. I change my min-max, for example, to say it's now 2.5. And we have a max of 6. I close this. It's updated my PFMEA. If I now go back, for example, to my control plan, and I reload, in some cases, I need to refresh my browser. I've now changed my class symbol. We've now changed our specification, tolerance information on the control plan. Okay, that's an example of how we link PFMEA specification onto the control plan. That same information is also applicable right here on my inspection plan with the updated data. Same thing is true on DFMEA. If you're design focused, simply choose the element you want to look at, choose the method you want to work with. You could be defining a requirement, I could be defining specifications. In this case, I'm actually defining my FMEA. There is my specification column. I have 2 of them in there. I can define many specifications for that function, and I can then tell the system which one is applied to which operation in final assembly. We can also see down here as well that we actually have information. These blue hyperlinks, this is where, if you remember back to Architect, where I made those data connections between the component or the subassembly to the parent. This is what it's telling me here. This is what we're looking at is linked data to say, okay, you have a failure mode of unable to charge at 12 volts, which was what I didn't want to have happen for my product in the field. It's telling me that you actually have 2 causes. And they're coming from this list right here. Degraded power, charging credits. If I click on this one, INS will take me down to the subassembly and says these are the effects for that failure, and it's linking it to the parent, right? If I'm in the parent, I can quickly see in here that I have all of my detections, my recommended actions, actions taken. Working in here is the same way as working with Excel spreadsheet, just tab across. Okay, double click, modify the text, enter text, copy paste, drag and drop. You want to link information? Sure. You can upload documents and attach them anywhere in the system that you want to, relevant for that particular failure mode. Okay. Within here as well, of course, looking at, in this case, a DFMEA, we have the option where we can filter information. So I could say I'm looking for a particular failure mode, or I could be on a severity, say I'm looking for a particular severity, like a 4 and a 5. I can filter the results. If I wanted to, I could then go to options. I could export that out as a PDF, send it back to an Excel spreadsheet for further analysis if I wanted to. Or let's say, for example, that we had to do a mass update. I can simply choose mass update. And I can say, actually, all of my 4s and 5s should be 6s and 7s. And I can then globally go and change for my project all of those FMEAs or the severity values to the new value. Okay. We can also do things as well where we can, for each system element, I can have different team members. Let's say Des is manufacturing, so I assign Des to the assembly process. Des only sees all of the process side. He would have read-only access to the design, but he can only work on the process. Okay? I can have multiple team members working on different elements. Each one of these is a system element. If you remember back to when we looked at the control plan, I'll just go there and show you. On the control plan, we had called out assembly worker AW1 on this particular control plan, right, for this assembly step. What INSYS does is it takes whatever you type in here for the assembly machine device, and it creates a system element on the left. I have a press, for example, I have assembly worker. Why it does that is, in some cases, you may need to do a machinery level FMEA, or you may need to do a job hazard analysis for the operator. So by calling it out as an independent system element tied to that manufacturing process, I can then do further analyses on it, right? One of our big clients is a tier 1. They supply all the OEMs. They have, and they saw this, and they said, this is brilliant, because now what I can do is I can bring in my work instructions, my standard operating procedures, I can bring in my job hazard analyses, and as I call out what it is, whether it's a machine or it's an operator, in my operation, I can then do for example, I could say assembly worker, I want to do an FMEA on that particular worker. So I could go into here and say, let's look at the assembly worker. What is his function? What is his particular failure modes? What is his effect? And I can do an FMEA on the assembly worker purely because I identified it in my control plan. Same thing is true if you're in the FMEA. I can choose this particular controller. I could go down to the plug of PCB. I could go to the plug. I navigate through my system, my project, simply filling in forms of information for my FMEA. If you're involved in other elements, let's say, for example, the controller failed in the field, and we have annoyed customers and they're sending it back to us. If I wanted to, I could simply go up to Risk Analysis 8D, and I could do a full 8D on just the controller. If I need to, based on the findings from my 8D, trigger a design review based on failure mode, DRBFM, I can tell the system I need to do a DRBFM on the controller. I could then simply go in, put reasoning for change, failed unit. I could tab across, give it a status, red because it's high priority. I could double click and I could bring up a function for it, and I could then fill in the rest of that information from the failure mode all the way through. And what it will do is I will inherit all of that data from the FMEA. I can then do my, in this case, DRBFM. If you need to do validation, sure, we have DVPNR, which we can go through. We also have RM49, if you're a med device, we have RM14971 built into the system. If you do internal audits, sure, we have auditing as well. So as one application, but based on your level of access, right now I have access to everything, you can then start to go through and look at all this functionality of the application, whether you are doing auditing or you're doing 8Ds or root cause, or you're involved in design FMEA through the process FMEA. It's a very scalable platform based on what you're looking for in your organization. And I know we have 10 minutes left, so Des, if there's any questions that have come up or anything you'd like me to cover in the remaining 10 minutes we have?
No, I don't see any of the attendees. We've got 24, 25 persons attending. For those of you who joined late, we had asked you to use the chat box. Feel free to enter anything. Mark, if you want to just show the emulation in the AIUG-VDA, that might just as a thing.
Sure. So let me see if I have that on this one. I may have to switch to a different system. Yeah, there it is. So what Des is referring to is, so I have an FMEA. This is what's kind of unique about our platform as well, is I have an FMEA. Let me show it to you. that was developed in 4th edition, the DFMEA, right? So you saw this earlier. So I have this DFMEA with these functions, failures, etc. You have traditional FMEA, right? If I want to see how this would look in the new AIG VDA guideline that came out, all you simply do is go to the system and say, I want to see it in this format. EINS will actually transpose all of the data into the new format, and then you simply fill in the blanks. So you see here, for example, all of that information regarding torque, the function, the characteristics, came across all the way over to then, obviously, if we did MSR, I can start to put in my MSR parameters, and then, of course, the optimization as well, which is there right now. So we actually have already converted, or if you want to think of it that way, convert over existing FMEAs directly into the new standard automatically. And that's applicable for this design and for process. And what I found a lot of clients are now doing is they're going in, creating a product like the controller, because it's in 4th edition already, creating a system element called controller, going up to options, import, so they pull the Excel file into EINS. As soon as it hits EINS, EINS then distributes that data out to wherever the linkages might be, along with being able to simply flip it over to the AIG VDA, so I can see it in the new standard. Right? And we continue to evolve this further, where you're looking at, for example, things like the MSR over here, where we have the system response and monitoring. Where those values get populated is we further enhanced Architect with a button right here called MSR. If you click on this, I can then choose a function associated to a failure to say if it's monitoring or if it's responding. As soon as I do, I then start to get these different blocks appear. Right? What it's doing, as I'm simply selecting these parameters, it's populating the MSR section of the AIG VDA guideline automatically, based off of what I select in here. And that's a new feature we added recently for Architect, where you can then start to build these monitoring and response parameters against subassembly functions that make up the overall product, causing or trying to monitor or prevent that particular failure from occurring. And those values would then appear. If we go back and look at that, we should see some of the information starting to come together on my MSR right over here. Let me reload that. Should, but there you go. Where is it? Somewhere here. In any event, because I have it filtered, that's why. But it is a very flexible, scalable platform. I also will mention it does translate as well, built into it. So if you are working in different languages, let's say I have an FMEA right here, you can actually go up and select the reference language, let's say German, and then what EINS will do is actually translate. So it says, okay, test wrong bill of materials, is this in German? The function prevent accumulator overcharging, is this in German? You see there's a dialog box also appear if you don't have a translation because it's not in the database, but you know because you speak German what that translation is. You can type it in and EINS learns from you, and it stores that into the translation database. So we do support German, Spanish, Portuguese, Chinese, Korean, different languages, and we continue to evolve that as well. We are a very progressive software company, so we continue to add on new functionality. Like I said, we have fault tree coming out end of the year. We do a P diagram coming out next year. So we continue to look at what is it our customers want, and we have 700 automotive. Understand what are the needs of the industry, where's the industry heading, and then we actually work on developing the application further to support those use cases. Okay,
so we're, I know we had a little bit of a 4 or 5 minute late start. I don't see any questions, but if there's any questions, please type it. We'll probably keep it open for another a few minutes into, because it was supposed to close at 8 o'clock. It's now 7:58.
Yep. Sure. There's my contact details for those of you. If you do have any questions, I can share. I'm not sure if you recorded this, but I can share the presentation. Okay. I have information I can share as well. So if anybody does have any questions, there's my contact information. There's my mobile number. reach out to me, give me a call, send me a text or an email, and I'm happy to arrange a further discussion around how we're helping a number of different organizations, whether they're the OEMs in automotive or they're suppliers to those, or they're pharmaceutical, they're med device. The application itself is configurable or adaptable to those organizations. So all of the clients we have, and as I mentioned, we have more than 800 customers total, 700 automotive. They're all using the same platform, but it's been configured to their particular methodology. So you don't have to change the way you do things. If you go back to my presentations, your process is enhanced and empowered by a tool because of the technology you're using, and your people are able to work more closely together and collaborate as they're working through their projects, whether they're design focused, manufacturing focused, they're making a med device or a drug.
Okay. Okay, so it's just at 8 p.m. If there are any other questions, if not, I don't know if Chaitanya wants to say anything, but on behalf of the ASQ Toronto Section, I'd like to thank Mark Chambers for sharing the whole integrated risk management approach, and also giving us an opportunity to see the actual technology in a live demonstration. As we said, his contact information is up here. If you do need to contact him for anything, feel free to do so. We are recording the seminar, the webinar, sorry, and that will be available, I think, on the ASQ Toronto website. I'm not sure. So, Chaitanya, do you want to say anything before we close?
I just wanted to thank Mark and Plato for your support for ASQ Toronto, and also like all our attendees to make sure that you register for December 11th ASQ recognition and networking event. Okay, thank you.
Okay. Well, thank you very much. We're going to close, and once again, thank you, Mark.
Thanks, no problem. Okay. Enjoy your evening.
Okay,
bye now.